Hello everybody, it's Mr. Ray with our next grade 10 applied math lesson. We're in Unit 1. We're talking about linear relations. So this is lesson 4. We're going to go a little bit farther into slopes of lines. We're going to look at things like positive and negative slopes, what that looks like on a graph. Also the steepness of a line. We're going to talk about what that means. And then we're going to talk about parallel and perpendicular lines and how they relate to the slope of lines and therefore how they relate to the equations of lines. So just a couple of continuing definitions here. Linear equation, this is very important throughout most of this unit. So whenever you think of a linear equation, we're using the slope Y-intercept form, which is basically looking like y equals mx plus b. This is a very important thing to think about. Anytime you're talking about a line and its equation, you should be immediately think about or write down y equals mx plus b, and always remember m is the slope of the line and b is the y-intercept of the line. So always think about that when you're creating an equation, that those are the two pieces you have to get, and you'll just plug them back in to y equals mx plus b. Okay, so the couple of new things here. Parallel lines, these are lines that actually never meet. They're the same distance apart, so they're considered to be parallel. And then perpendicular lines, these are special case of lines that, well, they're not parallel. They do meet, but they meet at a 90-degree angle with each other. Okay, and there's going to be a special relationship between the slopes of those lines, both parallel and perpendicular. Okay, some concepts here. A line with a positive slope goes up from left to right. So this would be going in this direction. It's not enough to say the line goes up, because the direction that you're going on the line is important, because I could, if I didn't say left to right, I could say this line's going down, or somebody else could say it's going up. So which is it? Well, if you have the same if you're thinking left to right all the time, it's either going up or it's going down. Okay, so that would be a positive slope, and then a line with a negative slope goes down from the left to the right. So as you're going left to right, it's like you're going down the hill. So that would be a negative slope, and a horizontal slope has a slope of 0. So that would be a horizontal line. It's not, think of it as a tabletop or desktop. If you put a ball on that table, it should not roll because there's no slope on the table. Okay, and the table should have a horizontal appearance. Okay, and this is an extra special case. This we won't talk about this too much, but a vertical line. So if you're going straight up and down, okay, this has an undefined slope, because if you think about what slope means, it's rise over run, and the run is left to right, and this line actually doesn't go left to right at all. So the run would be 0. So basically, rise over run, where the run is 0, you're dividing by 0, and that's not a good thing in math. That means it's undefined, so it has no slope. Okay. Since it has no slope, and it probably doesn't even have a y-intercept, it's very difficult to use y equals mx plus b. It's impossible, in fact. So a vertical line, we just use the equation x equals a, where a is the value of the x coordinate of all the points on the line. Okay, so just pick out the x coordinate at any point along that line. They're all going to be the same, and the equation would be x equals that value for x. Okay. Now, if we're talking about steepness, okay, we actually ignore the sign on the slope. So, for example, if you had a slope of -4 and another line had a slope of 4, well, it seems like the slope of 4 would be steeper because the number's bigger, but that's not the case. They both have the same steepness, because what we do with slope for this, if we're considering steepness, we ignore the negative sign. So we just drop the negative sign and then compare which one's bigger. So in this case, 4 and -4 would have the same steepness. Okay, now the relationship between parallel lines and the slope. If you draw a bunch of parallel lines, it's very easy to see that the slope is the same, and that is always true. Parallel lines have the same slope, so we can use that characteristic to create other equations of lines that are parallel, and also perpendicular lines. Now this is a little more complicated. They don't have the same slope as each other. That would mean they're parallel, but they do have a relationship. And what we do, we actually, if we want to find the slope of a line that's perpendicular, we take the negative reciprocal of the slope. So that's quite a mouthful, but it's really two parts. So in a quick way of saying what that means, you flip the fraction and you flip the sign. So for example, if I had a slope of 3/4, I wanted the slope of a perpendicular line to this line, I would flip the fraction, so it becomes 4/3, and then I flip the sign from positive to negative. So slope of -4/3 would be perpendicular to any line with a slope of 3/4. Okay, let's do some examples. So the first question is about the steepness. So I've got a bunch of values of slope here, some negative, some positive, fraction, decimal, 0, so just about everything. So we want to rearrange these slopes from no steepness, or the less steep, to most steep. So what we're going to do, I'm actually going to create I'm actually going to take each of these. I'm going to strip off the negative sign, because remember that doesn't matter for steepness. And where I see the fraction, I'm going to change it to a decimal, so it's easier to compare to the other numbers. So so the -4 changes to 4. We strip off the negative sign. The 3 is fine. The 0 is fine. -1/3. Well, I stripped the negative sign off first, so it's 1/3. And if I look at my calculator, 1 divided by 3 is 0.333. So I'll just round that to 0.33. Okay, and then I've got 0.5, that's already okay. And -1, strip off the negative sign. So now what I'm going to do is I'm going to create my list, and just to remind myself, I'm going from less steep on the left to the most steep on the right. So I want the lowest numbers first. So I'm going to go scan through here. What's the lowest number? Obviously 0. Okay, now I guess I go back there. That's the 0. So I've handled that. The next lowest number, and it's good to check these off so you don't look at them again or don't miss them. 0.33. So which slope was that? That was the -1/3. So I'm going to put it back in as the original slope, not what I modified it to. So I've handled that one. The next highest would be 0.5. Which one was that? That was 0.5. Okay, so I've done that one. Now we're into the integers. So I've got 1, and the 1 related to the slope of -1. So I've done that one. And then I've got 3, next highest, which was 3, positive 3. And then the 4 was really -4. So I put that as -4. So this may seem like a strange looking order here, but it relates back to stripping off the negative sign, because steepness doesn't care about which direction you're going. It cares about how steep the slope is. Okay, so let's look at the next example here. it says for each line, determine whether the slope, if the slope is positive or negative, just by inspection. So don't calculate the slope and then tell me. Just look at it, tell me, and then actually calculate the value to confirm that it was positive or negative. So the first one here, as I go left to right along here, you can see it's going up. So it rises left to right. So the fact that it's rising tells me it's a positive slope. Okay, and then if I actually want to calculate the slope, I could either use, the triangle, or I could use the slope formula with the y2 minus y1 over x2 minus x1. Either one would be fine. I'm going to use the graph. So I've already got 2 points highlighted here. So there's my triangle. So how much did I go up or down? I went from 2 to 3, so that's up 1 or plus 1, and then the run went from 0 to 4. Okay, so the rise was 1 and the run was 4, and I can't simplify that anymore. I could change it to a decimal, but I'll just leave it as a fraction. Okay, so that confirms that that's a positive 1/4. That confirms what we saw by just looking at the graph and seeing it went up to the right. Okay, the second graph here, you can see as you go left to right this time, you're actually going down. So it decreases as you go left to right. So the fact that it's decreasing or going down as you go left to right means it's a negative slope this time. So let's do a little calculation. Again, we'll use the graph. Slope equals rise over run. Okay, and if I got my 2 points here, here's my triangle. So I started at 5, I went to 1. So that's actually a decrease of 4 for the rise. And for the run, I started at 0, went to 2. So the rise is -4, the run is 2, and I can simplify that to -2. Okay, and that confirms the fact that I calculated the slope, it had a negative slope, confirms what we saw just by looking at the graph. Okay, so you don't always, if you have the graph, you can tell by looking at it whether it's positive, negative, or 0 slope. Okay, the next question, this has to do with parallel lines. So I give a bunch of equations of lines. I want to be able to determine two other equations of two other lines that are parallel to this line. Okay, so the first thing I do is, because I know parallel lines have the same slope and the y-intercepts are different, so from here I know that m is equal to 4. So if I want two parallel lines, I'm just going to create equations with the same slope, the same m value, but a different y-intercept. And this can be anything. There's an infinite number of right answers here, as long as you don't use +1. That would be the same line, obviously. So I'm going to use +3, and y equals 4x, say -2. So there's two lines that have the same slope as this line, therefore they're parallel. Okay, the next one, we can see this time m is equal to -8. So if I want to create two parallel lines to that line, I have to use m equals 8 for my new equations. Sorry, -8. I'm not sure if I said negative or not. So -8x plus 5, and this is just pretty random. Just make sure you don't use the 0 that you had on the original line. And then y equals -8x, say plus 12. Okay, so hopefully you get the idea. So the next equation, y equals 2/3 x minus 6. Well, the 2/3, that's our m value. So if I want two parallel lines, I need to use m equals 2/3 in their equation. So y equals 2/3 x, and this time maybe I'll use 0, so just leave it like that. And then y equals 2/3 x plus 10. Okay, this one's a little odd because you don't really see an m value here. There's no x. So if there's no x, that means it's 0x. That's the same as writing y equals 0x plus 5. Okay, so in that case, m is 0. So if I want two parallel lines this time, same idea, but it's going to look a little different because we won't have like an x term. It'll just be a constant. As long as it's not 5, we're good. So I'll say y equals 3, y equals -7 are two equations of lines, and these are both, you can see a slope of 0 means it's horizontal. These are both horizontal lines too. Okay, the last one here, this is going to be a little bit of work because this is not written in slope y-intercept form. You can tell that very easily by the fact it's not y equals something. So we're going to have to rearrange this so that we get it looking like that. So we're not actually changing the line, we're just changing the way the equation looks. So the first thing I'm going to do, I want to subtract 2x. I want to eventually just have the y here. So I'm going to subtract 2x from both sides. So when I subtract it there, I still have my positive 12. And now I'm going to divide everything by 3 to change it from 3y to y. So I divide the -2 by 3, and I divide the 12 by 3, and that works out to 4. Okay, so what do I need from here? Well, just like the other situations, I'm looking for the slope. So here I know m equals -2/3, so therefore two parallel lines to this equation or this equation, it doesn't really matter at this point, would be y equals, as long as I have -2/3 x, and as long as I don't use a 4, so how about a 14 this time? And another equation, just change the y-intercept again. How about a -8? So hopefully you see it's pretty easy to create equations of parallel lines to a given line. Just find the slope of the given line and use that slope for the two other equations that represent parallel lines. Okay, so change it a little bit. Same idea, but this time for each of these equations of lines, we want to create equations of two other lines that are perpendicular. Okay, so let's look at the first line. We've got y equals 4/5 x plus 8. Okay, so the first thing I'm going to do is I can see the slope is 4/5. Okay, now if I was doing parallel lines, I just use that slope, but this is perpendicular, so I have to create the negative reciprocal of that slope. And the way I do that, you could do this if you want. Rather than have two values for m that are different, I put a little subscript here with an upside down t that represents perpendicular, like they're meeting at 90 degrees. So this is the perpendicular slope. Now what I do to get that is I flip the fraction and then I flip the sign. So first thing, if I flip the fraction, that becomes 5/4. Okay, and flip the sign. Well, this is positive, so I change it to negative now. Okay, so if I want two perpendicular lines, I'm going to use this perpendicular slope. Okay, and just like before, as long as I have that as my value of m, it doesn't really matter what I put. And this time I can actually use any number because I'm not restricted by the original equation. I can even use 8 if I want, because these are obviously going to be different lines. Okay, so let's say plus 1 and 5/4 x minus 1. Keep it simple. Okay, how about this one here? So again, from the original line, we quickly find the slope as the coefficient, or the number that's multiplying with x. So here m equals -1/4, and if I want the perpendicular slope, again, I'm going to do a flip of the number, so 1/4. I change the sign from negative to positive, so the slope for the perpendicular lines has to be 4. So 2 perpendicular lines, and we're going to use this slope here, 4. Y equals 4x, we'll just leave it as 4x maybe, and y equals 4x minus 3. There's 2 examples. Again, infinite number of equations that will work. The only thing that has to be is the m value has to be 4. Okay. All right. So I did start off with fractions here intentionally, just because we're flipping the fractions. So these are actually easier to work with at first. So let's see how we do this with an integer slope. So we can see our slope is 0, so m is 4. Now, when I do the perpendicular slope, and I want to flip the fraction, flip the sign, well, it's not really a fraction, but I can always make an integer into a fraction by putting it over 1. And now when I flip it, it's 1/4. And then I flip the sign from positive, which this was, to negative. And if you think about it, well, the previous question, these lines are actually perpendicular to each other, because when I found the perpendicular slope for this one, I got 4, and which is the same slope as this, and when I did the other direction, find the perpendicular slope for 4, I got -1/4, so it's just the opposite directions. So those 2 lines are perpendicular to each other. Okay, so let's come up with some equations of 2 perpendicular lines. So this time we're using -1/4 as our m value. So, I could just put these at the beginning and just think of 2 numbers to throw in there. So let's go +7 minus 8, pretty random. Those 2 lines are perpendicular to this line. Okay, and again, the last example here, similar to the previous question. This line is not written in slope y-intercept form, so we have to do it. It's actually the same equation. So again, I'm going to subtract 2x from both sides, and then divide everything by 3. And 12 divided by 3 is 4, so that is the same rearrangement from example 3. So this time, just like last time, the slope for this line is -2/3. And if I want the perpendicular slope, flip the fraction, so that becomes 3/2, and flip the sign, becomes positive. So we use this for our 2 perpendicular lines. So they're both going to be y equals 3/2 x. And then just pick some random numbers, +11 minus 8. Okay, so that's how you create equations of perpendicular lines given a line. Okay, so the last couple of examples here are a little trickier, but we're going to use the same skills that we've learned in the past and today. So the first question, what's the equation of the line that is parallel to the line y equals negative 2x plus 8? And goes through the point 6, 12. Okay, so let's just, don't get overwhelmed with this. Just remember we're looking for two things. We're looking for the slope of our line and the y-intercept of our line. So first thing I'm going to do is looking at this other line. I know this other line has a slope of negative 2. Okay, so how does that slope relate to our line? Well, since our line is parallel, this is the value of m we're going to use. So I'm going to put an arrow here because we're going to use that. So the thing we're missing is the b value, but we do have this point here. So what this is telling us, the point is telling us that x equals 6, y equals 12 is a valid combination for this line. And we also know that m is equal to 2. So if I start with generic equation of a line, y equals mx plus b, I'm going to plug in the m, I'm going to plug in the x, plug in the y, and I'm going to figure out from that what the value of b is, and then use that for our line. Okay, so plug in y is 12, m is negative 2 from here, x is 6 plus b. So I've got 12 equals negative 12 plus b. Sorry, didn't leave enough room here, but what I need to do to get b by itself is I have to add 12 to both sides. So when I do that, I get 24 is equal to b, and that is our y-intercept. So I'm going to use that value of b, that value of m, to create our equation, negative 2x plus 24. And for this type of equation, there's only one correct answer. It has to be that. Okay. The fact that it goes through a specific point means that there's only one line that can do that, and that's this line. Okay. Our secret phrase for today is coffee mug. And we have one more example here. This one is similar to example 5. This time we want to find the equation of a line that's perpendicular to, turns out it's the same line as before, perpendicular to that line and goes through the point 0, 11. So it kind of looks very similar except for the fact that it's perpendicular this time. Okay, so again we'll do the same kind of thing. So the slope of this other line, m is equal to negative 2. Now, we don't want that slope because our line is perpendicular to this line. So this is where we calculate the perpendicular slope. And again, since the original slope was integer, I could put that over 1 if it makes it easier for you. So when I flip the fraction, it becomes 1 over 2. And the sign, flip the sign from negative to positive. So our slope, the slope of our line is 1/2 because it's perpendicular to that line. Now I go back to this point, and we encountered this on previous lessons. What we're trying to find is the b value, right? And we've been actually handed a gift here because this point is the y-intercept. How do you know that? You know that because the x-coordinate is 0. So that tells you that the y-intercept is 11. So that means that b is equal to 11. So we didn't actually have to do what we did last time, plug in the x and the y and the slope to get b. We found out that we got lucky and the point that was given is the y-intercept. So we have everything we need. We have the b value, we have the slope. So y equals mx plus b, plug in the m, so it's 1/2 x plus 11. And again, that's a unique equation. This is the only equation that would be correct. Okay. When we're looking for the other example 3 and 4, when we're coming up with lines that are parallel or perpendicular, there's an infinite number of correct answers. but as soon as I say it goes through a certain point, that limits it to just one possible equation. Okay, so I got some homework questions on the next page for you to practice this. We have one more lesson this unit, and that's how to graph linear equations. Okay, so until then, have yourselves a great day.